Hi everybody, welcome to the fourth track about how we can apply artificial intelligence techniques to container ports logistics. My name is Anibal Tavares de Azevedo, and now we're gonna explain on a great overview of this track. So before start coding, before start doing some code, we're gonna understand what we have done in previous tracks, and also use some cards to describe previously tracks, and also understand how this tracks connects to this track now. So it's very important this first class of this track because it will connect the previous tracks with the next track, the next class presented in this track. So let's start to remember what is your main purpose here. So let's see the things here. So the great question here: how to plan the port of operation? We try to ask by doing some important things. So we started to model the port by the ship. We started to model the ship storage space. So remember that we spent all the first track effort, the effort that we made in the first track was about to construct a class that describes the container ship space. Okay, it's not a very detail, but it's enough to model the container ship behavior of stacks, many stacks here. Okay, so it's a very simplified way, but it's okay to represent or to count the number of movements. What that is the most important thing that we can hold when we are dealing with container ships. So this is the first track. We spent a lot of class explaining this, how to build this. So after this, we have also to understand that in each port that ship is arrived, so we can load and unload cargo. So we have some rules how to unload and load cargo each time a ship arrives in a port. So we spent the second track describing a lot of how to build these unloading and loading rules, how this could affect the ship space, the container ship space. So here we have the container ship before unloading and after unloading, how the ship, container ship, would like. So we spent the second track on this. This was a great effort that we made here, and finally in the track 3, we spent a lot of time by explaining how we can coordinate these two classes to model the container ship travel through ports. So we need this transportation matrix that contains how many containers should be transported for future ports, for 4 ports. So if we are in port 1, we should load in port 1 2 containers which destination is port 2, 1 container which destination is port 3, and finally 1 container which destination is port 4. So using this information and how we can account, using the rules, how we can account the number of movements that we should made through ports. So we also translated these functions, these unloading and loading rules functions, in terms of lists of rules and how you can decode this list into names of functions, and how you can decode and use this inside a simulation. And after this, you can get the number of movements. Also, you can get other measures like instability measure, how your container ship organization is stable or not. For example, here we expand not much number of movements is not a great number, but the instability measure is high. This is the contrary. So the instability measure is very low, but we increased the container ship, the number of container movements. This is not good because each time we move a container ship inside a container and a container in a container ship, you will spend at least $200. Okay, but this cost is very very old. So at least maybe it's much more at this time since we have the container logistic crisis. So this value could be much higher than this. And now we have suppose that we have a combination of rules for port. Each port we have a combination of rules. Okay, so let's explain better this on this slide. Okay, no, not now. This is not now. Okay, so imagine that we are performing some we are performing container ship simulation through ports, and each port will have a rule that will be decoded in terms of unloading and loading rules. So after doing this, we can perform this simulation and compute the total number of movements by using this combination of rules. So the great question now is that we have a combinatory problem. So remember that, imagine it now, not this, not this, this. So now you can have many combination of rules here. For example, we have rule from 1 to 12. The range of integer number can be from 1 to 12 here, also here and here. So if you have more rules or more ports, this will increase exponentially. And also we have to test or find the best combination. We are hope to find the best, or if not the best, a combination that will spend not much number of movements. Okay, so what's the great question here? How we can do that? Not testing all combinations. So we propose here for the fourth track to develop here. Let's see, to develop what we call a genetic algorithm. And what is a genetic algorithm? The genetic algorithm have initial population. This is a list of lists. So you can see this. Each list corresponds to a combination of rules for ports. And we should evaluate these combinations. And using this decoding and rules and the simulation that we developed in the third track, we can compute and see, oh, this combination, we're gonna have this number of movements. This is not good, but the another combination is better. So we can save the better for a number of iterations. We can proceed with this, save the best, apply some genetic algorithm operations, crossover and mutation. We will see what this means through this fourth track. And finally, when finish this fixed number of iterations, we will get a high, an interesting value of function, a combination of rules which number of movements is very low, at least lower than the ones that were proposed in the initial population. So this is the basic scheme for what we're gonna develop. Okay, so this is not easy, but we will code in detail and explain each part of the code that make this more clear. So don't be afraid of this very complicated picture, because we're gonna explain in detail, step by step, and very slowly. And also we make the all code available in the description of the next videos. So I think this is the basic thing that we can get here. So thank you for your attention, and I hope you find this video useful and interesting. In the next videos, we're gonna start finally to code after this general view. This will, I hope this will make more easy, or at least to understand why we are doing the code. Okay, what is the purpose behind the code? So thank you again and see you on the next video. Bye!